Greetings and welcome to another rainy morning in the Philippines. It's rainy, ulan, and windy, Hagen. Anyway, it's not very nice outside, so I'm inside and I'm recording this. In this video, I'm going to talk about booting your computer. I'm going to talk a little bit about master boot records and legacy boots, and some about EFI or UEFI booting, and then I'm going to jump into how to multi-boot or dual boot or however many boots you want to do. The examples I'll be using I did in VirtualBox, so there's some issues with that and some differences, but they're easy to overcome. So hopefully this will be a help to people because I've seen a lot of questions on things like booting in UEFI mode and booting from CD-ROM and USB, and I'm going to try and explain how the whole thing works, which I think should probably answer some of these questions I see a lot of. So hopefully you enjoy this. Hopefully you get something out of it. It's time to get started, I guess. Let's go ahead and get started with BIOS and MBR, the legacy system that you don't find on any new computers nowadays. BIOS is an acronym for Basic Input Output Systems. It originated in 1975 with the CP/M operating system. I remember using CP/M. Yes, I'm that old. BIOS is usually installed as the system board firmware. It was the mid 1990s when configuration use utility became available. That's the standard. You push like the delete key and the BIOS screen comes up. MBR is master boot record, first sector on a partitioned mass storage device. It originated back in 1983 with the first large 10 megabyte, not gigabyte, not terabyte, megabyte mechanical hard drive. It contains a bootloader code and partition layout. This other one we don't hear too much, but it's their partition boot sector. There's some other names for this. It's stored as the first sector of a partition, not the first sector of the hard drive. It's specific to the operating system installed in that partition. The MBR bootloader code points to the partition boot sector, may also be referred to as the volume boot sector. Now that we've got the acronyms out of the way, let's move on to how our hard drive is laid out. Basically, we have an MBR, which is the first sector, and then our hard drives divide up into partitions. Each partition has a PBS at the beginning. If we look at the master boot record, we'll see that it's 512 bytes long, not kilobytes, bytes. It's very small, which is one of its problems. The bootstrap code actually only takes up the first 446 bytes. Partition table is 64 bytes. This is actually divided into four 16-byte sections for four primary partitions, which is another limitation of the MBR and legacy BIOS system. And then the last 2 bytes are a signature byte. If we look at the partition boot sector, we have a jump command in the first 3 bytes, and basically all this does is jump up to the bootstrap code, which is only 448 bytes. It's a little larger than the bootstrap code in the MBR, but not by much. In between there is the file system header, which is specific to the operating system you're running, and you'll have signatures at those last 2 bytes. This should be the same signature as you'll find in the MBR. So what happens when we start our computer? It runs the firmware on the system board. We often refer to this as BIOS. It searches for a hard drive. It searches them in a certain order and looks for the first one it can find a master boot record on, indicating it's bootable. Once it finds one, it uses the master boot record boot code to jump to the partition boot sector, which actually then chain loads the bootloader for the operating system, which is in that partition, which in turn will get the whole operating system running. The new system is UEFI and GPT. UEFI, Unified Extensible Firmware Interface. First iteration of it was in 1998. It actually took off with the open source version released in 2004. And it addresses multiple latent limitations of the BIOS MBR. For partitions, for example, the UEFI on a GPT can have 128 partitions. Old BIOS MBR was limited to a 2 terabyte maximum hard drive size. You get a lot bigger with UEFI. So GPT is GUID partition table developed alongside UEFI. In fact, its specifications included in UEFI 2.8. Identified partitions by their GUID or UUID global or universal unique identifier number introduced with the EFI system. And the GPT introduced the EFI partition or EFI system partition, which was capable of containing multiple bootloaders. So GUID, Global Unique Identifier, also referred to as UUID. This showed up initially in the 80s. For practical purposes, when your computer generates a GUID or UUID, it is unique. I mean, there is an extremely small chance that you could duplicate one, but it's very, very unlikely. It's unlikely enough to be considered unique. And this is a better way to identify your hard drives and your partitions. Now, GPT drive layouts can be displayed a lot simpler. We still have an MBR for legacy support, but this is followed up by the GPT header and the GPT partition table, which can address 128 partitions. And like I say, much bigger drives. Then we have the EFI partition and any other partitions. I should note that the EFI partition does not have to be the first partition. It just has to exist on the drive someplace. And then at the last part of the drive, we have a backup, and this is basically a copy of the GPT header and the GPT partition table, just in case. So our system board boots its firmware, which the firmware looks for an EFI NV or non-volatile storage. It's a small piece of non-volatile RAM where the boot order is loaded, or saved, I should say. The boot order is saved on the motherboard. And then this will look for a hard drive with an EFI system partition and an EFI bootloader within that system partition. Because this is a partition, it's a lot larger than the old MBR. Bootloaders can be a lot bigger, but this will chain to the OS bootloader. So the boot process is similar. There's just some advantages with space and size that come with EFI. So let's talk about the UEFI boot process a little more, since this is the new kid on the block and it's rapidly becoming the standard. So the firmware for UEFI is embedded on your system board. When you turn the power on, it does a post or power on self-test where it basically verifies certain systems on your system board are available and certain components are working. From there, we initialize hardware, and this is basically the hardware necessary for the booting the system. After we initialize hardware, we check the NVRAM for the EFI application to launch. This actually has multiple EFI applications in it, but they are in a specific order, and that's how they're read. If you can't find the first EFI or it doesn't go anywhere, then it'll skip it and jump to the second one and the third one and so on. Each installed OS should write its own bootloader to the EFI system partition, and it should also write its own information to the NVRAM EFI application. As I said, UEFI will step through the various bootloaders till it finds one that works. The bootloaders have an .EFI extension, and the UEFI system partition is a FAT32 format. Examples of possible UEFI bootloaders that might be in the list but skip would be if you had it set up to boot off a USB, but you don't have a USB plugged in, then it would skip that EFI and go on to the next one. Once it finds one it can use, it turns control over to the system it turns control of the system over to the bootloader in the UEFI system partition at that point. I say once it finds a usable one. Okay, now I want to take a look at a specific example, and this would be booting into the GRUB bootloader. So again, our system board firmware, it goes to our EFI NV storage list. It finds the first bootloader, or I should say it finds the first EFI entry in its list that will work. So it would skip USB if we don't have a USB plugged in, and since GRUB is mixed and the GRUB is there, it would use that bootloader. So it would go to your hard drive's EFI system partition and find the .efi file for the GRUB bootloader. In our example, on the EFI system partition, we have a GRUB bootloader, a Microsoft bootloader, and a UEFI interface bootloader. The GRUB bootloader would have been created by Debian, or not really created, it would have been placed there by Debian or any Linux distribution. The Microsoft one obviously would be placed there by a Windows install. And depending on the firmware on your system board, you may get the UEFI interface, maybe called a few different things, but this would be kind of like your old BIOS screens, but it'd be in the UEFI mode where you can adjust settings and things like that. And that would be the fallback, assuming no other device could be found. So going forward, since we're going to the GRUB bootloader, it will load the GRUB menu. And this is the difference between the Linux GRUB bootloader and say the Windows bootloader is the GRUB menu can have Linux, where if you chose Linux, you would boot straight to the Linux kernel and the Linux operating system, whereas if you chose Windows and you would have a certain period of time to choose once you booted, then GRUB would chain to the Windows bootloader and let the Windows bootloader boot up the system. Generally, when you're doing dual boots, you want to have something like a GRUB bootloader as your primary bootloader that can allow you to chain to other bootloaders as well as use its own information. Anyway, that was it. So at this point, you may be wondering how you go about adjusting things in your NVRAM for your UEFI, for the EFI system partition, or all that stuff. Because a lot of times when people have trouble with booting, it's not set up properly. Well, Linux has a utility called EFI Boot Manager. So again, we're running Debian in VirtualBox here, but when I enter EFI Boot Manager, it tells me boot current is 006 0006, which is a hex designation for that bootloader. And if we look in the list below, we can see 0006 is Debian. 0005 is a VirtualBox hard disk manager. 0004 Windows. 003 EFI shell. And if you look, you can see the boot order at the top, starting with 006, followed by 004, which would be Debian, followed by Windows, followed by 000, which is UIApp, 0203. Anyway, that's the boot order. I should note that if you want to find this out, you need to mount the EFI system partition. Otherwise, EFI Boot Manager won't return anything. Debian is automatically mounted at boot in systems like Arch. You can have it automatically mounted when you boot up or not. And if you don't have it mounted, you got to mount it to get any information. Now, if I use EFI Boot Manager -V, TAC-V, V for verbose, I will get a lot more information. Specifically, for example, let's look at the 0006 entry for Debian. We can see it's a GPT hard drive, and we can see the UUID number, Universal Identification Number there. And we can also see that it's mounted at /EFI/Debian shimx64.efi. That's the file, the EFI file that gets run when it enters this, when the system firmware passes control over to the UEFI. It runs this Debian shimx64. Now, if we look inside our UEFI partition, which again is mounted at boot/EFI/EFI, we can see we have a boot folder, we have a Debian folder, we have a Microsoft folder. And if we look inside the Debian folder, we can see we have several EFI files. Under normal conditions, you'd probably boot to GRUB x64 EFI, but we're using shimx64.efi. Shimx is a little plug-in program that does one thing and one thing alone. It allows secure boot. You can put whatever key signature you want in the shim x64. It'll open up an environment and then run the grub x64.efi bootloader. Grub x64.efi will not work in secure boot, so that's why we need the shim x64 if you're using secure boot. By default, Debian loads shim. A distro like ours, you would actually have to specify this, otherwise it would go straight to grub x64. But again, the shim is just a simple little program to allow booting when secure boot is enabled on your computer. So let's talk about the EFI boot manager command. Again, we went through the EFI boot mgr, views a simplified list of boot order and boot entries, and the EFI boot manager tag V gives you a more detailed list. If you want to actually change the boot order, EFI boot manager dash small o, and then the order in which you want to boot your various drives. We use a hexadecimal notation, and depending on the version of EFI Boot Manager, you may be able to get away with just using the single digit like 643152 instead of adding all those zeros. So that's a possibility. You just have to look at your man page for whatever distro and what EFI Boot Manager is actually using. EFI Boot Manager tag capital O will delete the existing boot order. This is another idiosyncrasy on some versions of EFI Boot Manager. You need to delete the boot order before you can write a new boot order. And that would what you'd use the O command for. Now, if you do EFI Boot Manager -V, capital V, this will just tell you the version number of the EIF Boot Manager program you're using. There are more advanced operations that can be done, like adding or deleting boot options, deactivating them, activating them. These are a little more complex than we want to get into here. At some point in the future, I will do a video exclusively on the EFI Boot MGR program and cover this stuff, but it's a little more complex than I want to get into now. Okay, that's it. We've gone through the boot process and hopefully answered some questions. A few things in this wrap up. One of the problems with using VirtualBox is it doesn't have any UEFI firmware. Well, not really anything you can access. And one of the questions I see asking is, when I set up a UEFI drive in VirtualBox, why can't I use the boot order with the CD-ROM, floppy disk, other hard drives? And the answer to that is that's an MBR boot order, because that's the default for VirtualBox, and that's what its pseudo RAM is set up for. When you go to UEFI, you have to set the stuff up in the EFI system partition using a command like EFI boot manager. That's why people, when they do UEFI and VirtualBox, can't use those checkboxes under the system anymore, because it's no longer looking there. But I hope I was able to answer some questions, or at least give you some insight into the boot process of your computer, especially with the newer UEFI mode. And I'm thinking in the future I'm going to do a video maybe in a couple months on a more detailed look at the EFI boot manager command. But for now, thanks for watching, and be with us next time. Okay, bye.